Okay, let's get started with 4.4, the real zeros of a polynomial function. So we're going to start this out by learning about the remainder theorem and the factor theorem. So first up, the remainder theorem. This says if you take a polynomial and you divide by the factor x minus a, then the remainder r is the result that you would get if you plugged a into p. All right, let's look at that in terms of an example. So if you have this polynomial, 4x to the fifth, and on, what happens if you plug 2 in wherever you see an x? Remember that this is function notation, so this is saying what's the result if x equals 2, right? E of x. All right, so we'll start by just plugging it in and evaluating directly. Evaluating directly means wherever we see an x, we're going to write down 2 instead. 4 times 2 to the fifth minus 3 times 2 to the fourth plus 2 times 2 cubed minus 7 times 2 squared plus 9 times 2 is 5. And so what do we get here? We're going to have 4 times 2 to the fifth is 32 minus 3 times 16 plus 2 times 8 minus 7 times 4 plus 9 times 2, 5. And so 4 times 32 is 128 minus 48 plus 16 minus 28 plus 18 minus 5. So 128 minus 48 is going to be 80 plus 16. It's going to be 96. Minus 28 would be 68. Plus 18 would be 78, 86. Minus 5 would be 81. All right, so P of 2 is 81. All right, so we have the remainder theorem to do this much more quickly using synthetic division. It's kind of a pain to have to plug 2 in over and over and evaluate. So instead, let's do this using the remainder theorem. The remainder theorem says do synthetic division. So we're doing 2. And let's put our coefficients, 4, negative 3, 2, negative 7, 9, and negative 5. Bring down the 4. We get 8. Negative 3 plus 8 is 5. We get 10. 10 plus 2 is 12. 2 times 12 is 24. Subtract 7, you get 17. Times by 2, you get 34. 34 times 9, so 30 times 9 is going to be 270. And 4 times 9 is 36. So we are up to sorry, we're not multiplying. Lost. I've lost my mind. We're adding straight down. 34 plus 9 is 43. Times by 2, we get 86. Minus 5, we get 81. What did we get before? We got 81. So this is also saying that if you plug 2 in, get 81. All right, a much quicker option than plugging it in and evaluating it directly. All right, your turn. See if you can do this. Go straight to the synthetic division. Don't have to plug it in each and every time. All right, negative 2 on the outside. Coefficients are negative 1, 2, negative 5, and 2. Negative 1, 2, 4, negative 8, negative 13, 26, 28. P of negative 2 is 28. All right, the factor theorem adds on to the remainder theorem. It says that if the remainder is 0, then x minus a is a factor. So we're saying, is this a factor? Only if the remainder is 0. So let's figure out whether x plus 2 is a factor of this polynomial. So remember, when we do synthetic, we're going to use the 0. So the 0 here is not positive 2, but negative 2. And our coefficients are negative 1, or sorry, positive 1, negative 2, negative 5, and 6. Let's see what happens. 1 comes down, we get negative 2. We get negative 4. We get positive 8. We get negative 3. No, sorry, we get positive 3. And so then we get negative 6. Hey, look at that. The remainder is 0. It is a factor. So what has just happened? This can be factored into x plus 2, which we had from the original, times this. which is x squared, 1x squared, minus 4x plus 3. All right, we want to factor completely. Once we get to the x squared portion, we are able to factor this on our own. What multiplies to 3 and adds to negative 4? The answer would be x minus 1, x 3. There you go. Your turn, see if you can do it. All right, we put 1 on the outside. Coefficients are 1, negative 4, negative 7, and 10. Down, negative 3, negative 10. And it does indeed work out. So now we have x minus 1 times squared minus 3x minus 10. And does anything multiply to negative 10 and add to negative 3? The answer to that would be x plus 5 and x plus 2. All right, we can do this twice actually. You don't have to just do it with one factor. Let's do the exact same thing. So on the inside, we've got 1, negative 15, and 36. Excuse me, I didn't follow my own instructions. We need to have placeholders. This is actually x to the 4th plus 0x cubed minus 13x squared plus 0x plus 36. So to do the synthetic division, we would need a 1, a 0, a negative 13, a 0, and a 36. And on the outside, we can start by picking either one of these. So let's start by using the x minus 3. So we'll put 3 on the outside. 1 comes down, get 3, 9, negative 4, 12, and that does turn into negative 36. So x minus 3 is a factor. Now we're going to keep going. To keep going, we're going to keep going from the answer we just got. Don't worry about the 0 because we said it is a factor. Let's divide this answer by x plus 2. So we'll put a negative 2 on the outside. Keep going. Negative 2, we get positive 4. That's a 7. Negative 14. That's a negative. What did I mess up here? Everything looks good. I brought a 1 down and made a negative 2. There we go. 1, negative 2, 1, negative 2, negative 6, and positive 12. It's the end of a long day here, people. All right, so we ended up with is we've got x minus 3. We've got x plus 2. And then we have from here x squared plus x minus 6, which can be factored into x plus 3 and x minus 2. Your turn. All right, 3 on the outside. 1, negative 1, negative 7, 1, and 6 on the inside. 1 times 3 is 3. We get a 2, a 6, a negative 1, a negative 3, a negative 2, and a negative 6. We get 0. And we'll go again a second time around for the negative 2. So we'll get negative 2 here, a 0, negative 1, and a positive 2. That's 0. So we end up with x plus 3, x plus 2, x squared minus 1, and that does factor into x plus 1 and x minus 1. Okay, just one thing we want to point out here is that a polynomial cannot have more real zeros than its degree. So if you have an x to the 4th, then 4 is the max real zero. Okay. If it was x to the 12th, then 12 would be the max real zeros. Okay, the rational zero theorem, I think we're actually going to skip this. We're going to come back to that. So what we want to do with this instead is we're going to take this problem and we're going to see if we can factor this all the way down. So we're going to do 2 examples of this. And to do this, you're going to use your graphing calculator. So pull out the graphing calculator and follow along with me. Where's my graphing calculator? There it is. Let me clear this off. All right, so here's what we want to do. We're going to go y equals. If your plot is turned on, highlighted here, use the up arrow key and hit enter to make sure it's turned off. Okay? So you want none of the plots here highlighted. If you have anything in your y1, just go ahead and clear it. And let's go ahead and enter this is. So this is x to the 4th. Let me go ahead and pause the video real quick while I enter it. Okay, so I've entered it in. What I'm going to do is we're going to go ahead and graph this. But before we do that, we want to make sure that the zoom is at a good place where we can actually see the graph properly. So go ahead and hit zoom at the top and choose option 6, zoom standard. What that will do is make your left, right, top, and bottom coordinates 10 to -10. So we're going to see most of this graph. So you can see that this graph continues down below. It turns around down here. We just can't see it all. And it is crossing at, it looks like -2 and +3. All right, so we just look at the graph. We're going to use the graph on the calculator to figure out what the factors are. So it looks like -2 and +3. So we think that the zeros are -2, +3. So let's go ahead and test this out. We'll plug in -2 and go synthetically. 1, -1, -5, -1, and 6. So 1, -2, -3, +6, +1, -2, -3, and -6. That's why it wasn't coming out. +6 and 0. So -2 checks out. Let's try +3. 1 and 3 and 0 and 0 and 1 and 3 and 0. So because of this, the 3 also checks out. And so our factorization is x plus 2, right, minus a negative, x minus 3, and squared plus 1. All right, and so x squared plus 1 is not factorable, so we are done. And so you'll notice that this is an x to the 4th problem. So we can have up to 4 real. Now real means it's going to cross the x-axis. Okay, so real zeros. When we look at our graph, it only crosses in 2 places. So we know that we have 2 real and then 2 more because of the x squared, and these are going to be imaginary. We'll deal with that in the next video. All right, your turn. See if you can do this. All right, so when you graph this, it looks like you cross at -3 and 1. You plug that in correctly, so we'll plug in -3. 1, 2, -2, 2, and -3. 1, -3, -1, 3, 1, -3, and 1 and 3, so that works out. And it looked like it crossed at 1 also. 1 times 1 is 1, that's a 0, that's a 0, that's a 1, that's a 1, that's a 0. And it checks out, so again we would have x plus 3, x minus 1, x squared plus 1. We're done. Okay? All right, so we could try one more of these, but it's the exact same problem. So let's go ahead and try this one in class. Let's call that good for this video. All right, any questions? We will see you in class.